Okay, so once we've pulled down our exponents in parentheses, sometimes you won't need the parentheses, but sometimes you will. Then we are going to distribute if necessary. Solve for x. X is on one side, everyone else on the other. Factor him out. X is on one side, everyone else on the other. Factor out x. Okay, so that's a lot of steps for if no. And side note, I like these type of problems. This is a college algebra level problem, not an intermediate algebra level problem like the ones kind of before this. So I'm more likely to put something like this on the test, especially because x is on one side, everyone else on the other, and factoring x out is a theme that we have seen quite a few times at this point this semester, and it's something you're going to have to know how to do in calculus. You're going to do it there for a different reason, but it is an algebraic technique that you need to know. So I am going to distribute my ln of 7 both places and my ln of 2 both places. And so this is negative 4x ln 7 plus 1 times ln of 7 is ln of 7. We don't stick anything in our calculator until the very end. That is going to equal 4 ln 2 plus 3x ln 2. Next, we want to get all of our x guys on one side, everyone else on the other. To do that here, I'm going to plus 4x ln 7 plus 4x ln 7. These are not like terms. Ln of 2's and ln of 7's don't mix. So I just have to write everyone out on this other side. And I can also at the same time minus 4 ln 2, minus 4 ln 2. Again, these two are not like terms, so I just need to write them both out until I'm ready for my calculator. And so this guy cancels. So this is ln 7 minus 4 ln 2. And my 7's a little ugly. That is going to equal 3x ln 2 plus 4x ln 7 to, I'm just going to squiggle down the side so there's a little barrier there. Next, to finish solving for x, we gathered all of our x guys on one side, everyone else on the other, because to solve for x, now we need to factor them out. So ln 7 minus 4 ln 2 is equal to x times 3 ln 2 plus 4 ln 7. To finish solving for x, I'm going to divide both sides by 3 ln 2 plus 4 ln 7 divided by 3 ln 2 plus 4 ln 7. And my exact answer for x, which does need to be on its own line, is ln 7 minus 4 ln 2 divided by 3 ln 2 plus 4 ln 7. This is my exact answer. Then I'm going to put that whole thing in my calculator and get my decimal approximation. Now, with my calculator that I have to put a parenthesis around everything on top and everything on bottom for it to calculate it correctly. You need to know how to work your own calculator. So ln of 7 minus 4 ln 2 divided by, in another parenthesis, 3 ln 2 plus 4 ln 7 parenthesis, parenthesis, and I hit equals, and my calculator tells me that this is about negative, a negative looks weird, 0.0838. Goes next to the second 8 is a 1, which is telling it to stay. One other reminder, even if you write down all of the decimal places in your calculator, it is still rounded. Your calculator rounds the last digit that you can see. You don't have to put these parentheses on your paper here. I just wanted for you guys to see, depending on your calculator, you may have to put parentheses into your calculator on top and bottom for it to calculate correctly. Okay, next, example number 5. 9 to the x equals 3 to the x plus 12. If there is an extra guy floating around, plus 12 does not have an x in his exponent. That is not 0. If yes, make one side equal to 0. Make one side equal to 0. U sub. So the difference between the two of them is this extra 12 here changes things for us. So I'm going to minus 3 to the x, minus 3 to the x, minus 12, minus 12. And that one little difference here gives me 9 to the x minus 3 to the x minus 12 equals 0. And this is going to be a u sub. When we u sub, we look to our middle term, but we actually need for this to be a 3 to the x also. And 9 I can rewrite as 3 squared to the x minus 3 to the x minus 12 equals 0. Or when we raise a power to a power, we multiply. So this is 3 to the 2x minus 3 to the x minus 12 equals 0. Or last thing, I do want to be able to write this front guy as a middle guy squared. That's why I'm going to u sub. And 3 to the x squared, when we raise a power to a power, we multiply. We would get back a 2x. So it does in fact work here. Minus 12 equals 0. And that is why we are going to let u equal 3 to the x, just the middle term, not his leading coefficient. That means that we will have u squared minus u minus 12 equals 0. And this looks like something that we should know how to solve. Hopefully he factors. U and u, who multiplies to be negative 12, adds to be negative 1. My vote is negative 4 and positive 3. And then u minus 4 equals 0. U plus 3 equals 0. To give us that u equals 4 and u equals negative 3. And then I am going to put back in my u's. Put back in my x's. So 3 to the x equals 4. and 3 to the x equals negative 3. And can I write both? I only have one guy with x in his exponent. Can I write both sides in base 3? 4 cannot be written as a base 3. And so that is why I'm going to log base 3. 3 to the x equals log base 3 of 4. Log base 3 of 3 to the x cancels and x falls out. That's going to equal log base 3 of 4. Now, 3 to the x equaling negative 3, that may seem like that is one where I can write both sides in the same base, but it is not possible for you to tell me an exponent that we can raise 3 to in order for us to actually equal a negative. So this is not possible. Slash, if you did try to log base 3 both sides, like I did over here, when you go to type x equaling log base 3 of negative 3 into your calculator, which you would do as ln of negative 3 divided by ln of 3, it would tell you something like domain error, because what we plug into a log or an ln cannot ever be negative, which is also why this can't work. Not possible. Also, not possible to ln the negative 3. So, then we use the change of base formula. X equals ln of 4 divided by ln of 3. And then we type that in our calculator to get our approximation. So ln of 4 divided by ln of 3, which is 1.2619. And I did say before, but I'm going to say again, I need to see all 3 of these steps on your quiz or test in order for you to get full credit on a problem like this. Now I'm going to pause my video and then we're going to start doing logarithmic equations.